All right, we're going to jump right into a genetic condition that's surprisingly common, but you'd probably never even know you had it. It's this wild story about a tiny enzyme, a battle happening inside our own red blood cells, and an evolutionary twist that is just fascinating.
So first up, let's just get a sense of the scale here. 400 million. That's how many people around the globe are estimated to have G6PD deficiency. I mean, that makes it the most common enzyme deficiency in the entire world, period. And you see it a lot in places like Africa, Asia, and the Mediterranean.
But here's the crazy part. Even though it's so incredibly widespread, most people who have it show no symptoms at all. None. So you've got this amazing paradox, right? It's everywhere, but for almost everyone, it's totally invisible. That is, until something very specific comes along and triggers it.
Okay, so to really get what G6PD deficiency is all about, we have to shrink down. I mean, way down. We're going to go right inside our own bodies to the microscopic level of our red blood cells.
So your red blood cells have one huge job. They're like these little oxygen delivery trucks zipping all over your body. It's a crucial job. But on their delivery routes, they are under constant attack from inside our own bodies.
And that threat? It's called oxidative stress. The best way to think about it is like cellular rust. It's caused by these unstable molecules that are just a normal byproduct of our bodies making energy. But if you don't keep that rust in check, it can do some serious damage.
Okay, so in a healthy red blood cell, your body has this awesome three-step defense system. And the hero of this story is the G6PD enzyme. What it does is create this molecule, NAPDH, which is kind of like a rechargeable battery. It powers up the cell's antioxidant defenses. And once those defenses are charged, boom, they neutralize the oxidative stress and the red blood cell stays safe.
All right, so that's how it's supposed to work. Now, let's look at what happens when that shield is weak, when that protective enzyme isn't running at 100%.
And this really shows you the difference, side by side. On the left, you've got your protected cell. Its G6PD shield is strong. It brushes off oxidative stress no problem. But on the right, that's the vulnerable cell. The shield is weak, so that oxidative stress just builds, until it completely overwhelms the cell, causing it to literally break down way before it's supposed to.
And we're not talking about a slow process here. This is a sudden, rapid breakdown. It's called a hemolytic crisis. It happens when the cell gets hit with so much oxidative stress that its weak defenses just can't keep up. It's like a dam bursting.
When a crisis like this hits, your body sends out some really clear warning signs. All those broken down red blood cells release this stuff called bilirubin, which can make your skin look yellowish. That's jaundice. You might also see dark urine, feel short of breath, or just be incredibly tired because, well, your oxygen delivery system is in trouble.
So this brings us to a really important point. For the most part, this isn't about a cure. It's all about management. Because most people don't have any symptoms day to day, living with G6PD deficiency is really all about knowing your triggers and avoiding them.
And those triggers usually fall into three main buckets. You've got certain foods, a specific list of medications, and then just the major stress on your body that comes from a bad infection or some other serious illness.
Now, when we talk about food, this is really fascinating. People have pointed fingers at lots of different foods over the years, but look at this. The really solid clinical evidence. It points to one thing above all else, fava beans. You might know them as broad beans. In fact, this connection is so strong that the condition is sometimes just called favism.
And it's a similar story with medications. It's not all drugs, but a pretty specific list of ones to avoid. You can see some of the big ones here, an antimalarial called primaquine, certain antibiotics like sulfamethoxazole, the list goes on. And for someone with G6PD deficiency, knowing which drugs are on this list is, absolutely critical. So, this raises a huge question, right? If this condition can be so dangerous, why on earth is it so common? Well, the answer is just incredible. It's this much bigger, evolutionary story, one that basically turns this deficiency into a kind of superpower.
And believe it or not, people have known something was up for a long time. We're talking ancient history. There are legends about the dangers of fava beans going back forever. The Greek mathematician Pythagoras, that Pythagoras, actually forbade his followers from eating them. And it wasn't just some weird superstition. It was almost certainly an ancient observation of a very real biological thing.
And here it is. This is the key. You take a map of where G6PD deficiency is common, and you lay it over a map of where malaria has been a huge threat, and the overlap is almost perfect. That is not a coincidence.
Yeah, this quote just says it all.
Having G6PD deficiency is actually a huge survival advantage in some parts of the world. It gives you protection against malaria, and not just any malaria, the deadliest form, caused by Plasmodium falciparum.
So how does that even work? Well, the main theory is pretty cool. Those red blood cells that are a little more fragile, they actually make a terrible home for the malaria parasite. It has a hard time growing. So the infected cells get cleared out by the spleen much faster, which stops the disease in its tracks. The cell's biggest weakness becomes its greatest strength against this parasite. Which leaves us with this incredible final thought. Should we even call G6PD deficiency a disorder? Or is it really more of a powerful evolutionary compromise? You know, a genetic trade-off where for thousands and thousands of years, the risk from something like fava beans was a pretty small price to pay for having a built-in shield against one of the deadliest diseases humanity has ever faced.